By the end of this video, we will learn how to send static values from ESP8266 Wi-Fi module to Firebase. Then later, these static values will be displayed in a line chart and cards. And whenever a new data is coming from the ESP Wi-Fi module, it is updating the Firebase, and whenever an update is detected by the application in the Firebase, it will be displayed and dynamically updated in the line chart and in the cards, as we will see in the following demo. And now the ESP is connected to Wi-Fi and is trying to send data to Firebase, and we can see that the first data was sent. It is here, and it is added to our dashboard. We can check it. You can see here the value is 11. The timestamp is here. Okay. Now the second value is added. It is here 92, and the statistics are also updated each time a new data is sent. We will wait 40 seconds as mentioned here by our code. We can see, okay, now the third data is added, 40 the third value. We can see in Firebase, okay, it's added now. We can see that it is added also here. We have 3 data. Here is the 40 values. It was sent at 4 hour and 20 minutes. This way we are sure that our ESP Wi-Fi module is sending successfully the data, as you can see here, each 40 minutes, and we are having really real time data shown in Firebase and in the Angular dashboard. We have to create an Angular project, and in order to do that we have to go to the directory in which we are going to create our project. We have to type cmd, as I am using Windows, and in order to open a command prompt in a directory, we just have to type cmd, then I type enter, then I have to install Angular using npm install -g Angular CLI, and wait until it's installed. As you can see here, it's installed successfully. The next step is to create the project using ng-new and the name of the project. Okay, I will call it 3 ESP8266 Firebase Angular, Firebase chart, as I will use the ESP later, the IoT module ESP8266. We wait until our project will be created. I will type yes. I will use CSS, and we will wait about 2 to 3 minutes in order to get our project created successfully. And finally, we get this message. We are sure that our project is created. We have to navigate to it using cd and the name of our project. Then we open it using VS Code. I use this command to open the project using VS Code dot. Okay, we can see here that our project is created. There are several components that we can use using ng-zorro. For example, I will use some of these components for the layout. We can choose any layout, for example this one or the other. We can see the codes here. We can copy the code or copy the command that generate the code for us, or show the code here, and based on this codes I will create my layout. Okay, And using ng-zorro, I have added some code in order to create a sidebar and the layout of our application. I will explain to you briefly the code of the layout. We used the ng-zorro, as I said. We used the NZ layout and as the NZ slider for the slider here. Okay, and inside the slider we have to collapsible function, and we are using is called boolean variable in order to make the collapsible possible, and inside of it we added an image of the dashboard and an example a title. For example, I used the example dashboard here, okay, and the icon here, and the theme I'm using is the dark. And for the inline collapsed option, we are using the variable is collapsed, as I said, and when we click on it, it's collapsed. Okay, and inside our and here we have two options: menu unfold and menu fold, depending on the variable is collapsed. And we should not forget to add necessary modules concerning the ng-zorro modules that we have used in our HTML component. These modules are NZ icon, NZ menu, React forms, NZ layout. We should add their importations statements in the app.module.ts, as we can see here. So the next step is to add grid component based on ng-zorro grid components. So we have to go to ng-zorro, then type grid in the components section, and we can see here the details of how we can configure our grid component, the necessary syntax that we should use. So here we have each row is divided into 24 columns, and based on the value that we put, we get our partition. For example, if you want two columns into our row, we should use column 12 two times, because 12 plus 12 equals 24. And if you want to divide our row into three parts, we have to use column 8, etc. Okay. And now I should add a grid component to my project, and to do that we simply type ng generate component, and I will create a folder called grid, and I will put my component inside of it, and it will be called grid. Wait until it's generated. You can see that it's successfully generated inside my grid folder. After that, I have to add the NZ grid module in order to use the NZ grid component in my project. I added its importation, and I add it into the imports list. After that, I have added some codes inside the grid HTML code, and I want later to put the chart above using all the row. And then I will divide the next row into three parts. Each part will contain some cards. And as we can see here, our grid is divided successfully. We have here above one row that will contain later the line chart, and below we have three columns. Each column will contain a card that will present some statistics that we will get after some calculations that we will perform based on the data that will update. And now the next step is the addition of a pie chart to our project. We add this library using this command and wait until it's added. You can see here that we don't have any vulnerabilities. We can use the next npm audit fix if there was some issues with npm, using force mode to avoid errors. And as the documentation says, we should add the import statement into the app.module.ts. Now we can use our chart in our project. And now let's create a component that will hold the line chart that will contain the details and the data about temperature and humidity. That will be a line chart. And in order to do that, I use this command and I try to create the component inside the grid folder. Okay, let's see now. As we can see here, it's added here, the component. And inside this component, we are going to add the line options and HTML code of the line chart. And here are the options of our temperature humidity line chart component. We set the type, the text of the title. The x-axis will contain the list of categories, and for the data, we have to set list that contain the different values that will constitute our data and the name of each series. For the temperature, we have name and data, the same for humidity. And for the HTML part, we can create a division that contain the ID of the humidity and temperature chart. And during the initialization of the component, we have to create the chart using highchart.chart and the name of our chart and assign the options that we mentioned to this new chart. And this will be the ID that we have used inside the division in the HTML code. And for the grid component, we have to add the selector of the component that we already have created. And as we can see here, the charts are created successfully. The title is the same that we have created, and we have here the legend, and it is responsive and awesome. Now we have to create a Firebase project, and in order to do that, we have to go to this website, which is cancel.firebase.google.com, and create a new project by clicking on add project. We have to give a name to our project. I click on continue, then I click one more time on continue. I choose an account. For example, I will create a new account. I will call it our country. I accept. So we have to create a project. And now our project is created. We have to click on continue. And now we have our project is ready. After that, we have to create a web application inside our project by clicking on a web icon here. We have to give a name for our web application. For example, I will call it Google Map Angular. We can click on also set up hosting for this app. Uh, we click on register app. We can see here are all the commands that we will use in our Angular project and the configurations. We click on next. We click on next one more time. Here we have all the commands for the logging and initiation and deploy. After that, we finish by clicking on continue to console. Now we can see here that a new web application is created inside our project. We click on this icon and we can see all the details of our web application inside our. And once we have to use Firestore in our Angular project. We have to create a Firestore database. We can say test mode here. We click on enable, and now Firestore database is created successfully. And we can modify here the rules in order to extend the testing period. Here we can see, yes, we can see 23 here, so that we won't have an issue for dates and expiration dates. Okay, I will click on publish, and you can use the data and this Firestore until the next year. Okay. And now we have to add Firebase to our project, and in order to do that, we just use this command and wait until it's added to our project. Okay, now it is added successfully to our project. After the creation of, after the installation of Firebase into our project, we have to log in using Firebase login. A window will open for us to sign in. We choose the mail that we have used to create the Firebase project. For me, this the email. And then we should say hello. Okay, now we are logged in successfully, and here a message in the terminal that we are successfully connected. After that, we have to initialize Firebase, and we should use Firebase init. We should say yes features that we want to use. We can type A to select all the options. We will use an existing project. Okay, now we should select a project. We can go to Firebase console and take a look at the projects. For example, for this project, we can check its settings. We can see here the ID is map chart Angular. So I will use it, this one. We can type enter, enter one more time, enter one more time. These are files for the configuration of Firebase. Yes, should install the dependency. You can say yes for using our public directory. Emulators, we can say yes for all of them. Yes. And now the installation and initialization is complete. We can work with the Firebase with no issues. After that, we have to add the Angular Fire module and the Angular Fire Analytics module, Angular Firestore module to our Angular app module, and add them to the list of imports here. Here are the modules. We add them in the imports list. Then we should add the environment.firebase. And in the environment, we should add the details of configuration of Firebase of our project inside Firebase, especially the API key. And now we are going to create a service that will handle our connection with Firestore in Firebase. And in order to do that, we have to simply use ng-generate service and the folder that will contain our service, which I will call services, and then one subfolder that I will call it Firebase charts, for example, or temperature temp humidity charts. Then the name of the service will be Firebase PMP view. Okay, that it is created, and inside of it we will put all the necessary code to maintain our connection with Firestore. And now let's create an interface for our temperature. Then we should create a folder for it. We will create here in the app a new folder which I will call models, and inside of it I will create another folder which I will call charts, and inside of it I will create a new file which I will call temperature humidity or temperature interface.ts, and inside of it we will declare our interface. Then inside our service we should add all the necessary importations, and we should not forget the temperature model that we have already created. Then let's declare a variable which will be called the temperature collection inside our class. Then we will add an observable. After that, we will make dependency injection inside the constructor, and inside our constructor, we'll add this code that will detect any changes in our file store. Then it will load the new data for each change. And here inside our service, we have a type, parameter of type Angular Firestore collection, which is called temperature collection. And here the temperature collection is the interface that we have created, which have parameters like the ones inside the Firestore uh, collection. And we created an observable of type temperature model, and there will be an array of temperature modules, which means that will be array, and each element of the array will have here the temperature and the time uh, parameters, and the constructor here inside of it we have injected a firestore service, and this firestore service will allow us to detect any changes later, and for our temperature collection that we have created, it will take as a value the firestore service dot collection, and we should put the name of our collection inside the Firestore. As you can see here, it is called temperature data, and it is the same name that we have put inside our service, which means also that whenever a change that occurs in the Firestore, the new data will be updated and added to the temperature data. Now, inside the TypeScript of our component, we have added some modifications here. We have added the Firestore Firebase temperature humidity service that we have already created and explained. And inside the constructor, we have added an object of type the service, and some arrays that will appended with the data that is coming from through the service. And here, when our component is initialized, we subscribe to the observable temperature that is created here using the object service here, and for each element that is coming from the subscription, this object will contain the new data that is coming from Farso. Okay. Then, if we have data for each element in the temperature data, we have a row here, and this row will contain the temperature and the date. For the temperature, it will be appended directly into the temperature values. But for the date, which is called time here, we have the seconds here in the time that is coming from Firestore. We should convert it to the valid date format using this formula, and the temperature timestamp then will be pushed by this new temperature time date format that we got. And categories here will contain the temperature timestamp, and the series 0 here will contain the data. And finally, here we create a chart. Options will be here, the title, the credit, etc. And for the categories here, as I said, it will contain the timestamp that will contain itself the data that's come from Firestore and converted. And for the series and the data, it is coming also from the Firestore and using the subscription. And here is our application that is connected to Firestore, and the data inside Firestore is represented in real time here in the chart. If we delete or update or insert a new data into our Firestore, it should be detected automatically by our application. And let's test this. We can add a new document and make an auto ID for this document, and we should create the temperature field here, which should be a number, and we add 99, for example, as a value for the temperature, and we should add a field which is the time, and it is of type timestamp. We select the current timestamp, then we click on save. We should see this new document represented in our chart. Okay, let's see together if it is added. Okay, we can see it is added successfully here, the date which is 10 December, and the value 99. Now we can modify also the documents, and the changes also should be directly detected by our application. For example, here I will make it 66, and we should see this change directly into our application. We can see it is modified successfully, and we can delete a document, and we should see that it is also deleted in our chart. Okay, start deletion. Then we can see here that we have only three elements, and the fourth element is deleted from our chart. We can conclude that our uh, chart and application is representing real-time data. And now we are going to add these cards in our application. We are going to use ng-zorro cards, and we can take a look at them by clicking card ng-zorro. Here we will see some examples. We should import it, and here are some examples, basic example, etc. Card with picture, for example, a grid card that support more content configuration. Let's take a look at its code, and we will insert this code inside our grid. Let's go to our grid component, and as we can see here, the place of cards will be here. And now let's import the module in our app module, and then scroll down and copy the code that we saw together. Code inside our grid component. Here, instead of the temperature card one statement, we passed the code of the card without forgetting the addition of some modules. For example, the NZ avatar here. We should go to ng-zorro and search for avatar here. Then we can get the module that we should import. We can see here that the error disappeared. We save our grid component HTML, and let's take a see at our application. Okay, now it is add successfully the card. We can modify it, of course. Instead of the picture, we'll add some details about our temperature chart, some mathematical statistics about our chart, for example, the maximum or the minimum. We will put them together, the maximum, the minimum, the average, and the median, for example, in four different cards. Okay. Now we have modified the content of the code of the card. We choose only this statements that display the highest temperature and an icon of a hot temperature plus the title maximum temperature, as we can see here. And the result of this card is here. Now we will repeat the same thing for the other cards with the static values. Then these values will be concluded dynamically from the data of the line chart. After that, we copy and paste the same code of this card into the other columns, the other three columns, and we change the title each time. We put now static values, then these values will be replaced by dynamically value that we will get from the data of the line chart. And finally, as we can see here, the cards with the new titles and values are added to our interface. And now we are going to make some statistics for our data. And in order to do that, we have simply to install this library, this Node.js library, which is called simple statistics. And in order to do that, we have to simply type npm install simple statistics. Then we can use it this way. In our ES file of temperature, we have to use the importation of all the functions inside the module simple statistics like this. And then we can use it. For example, if you want to calculate the average, we can use temperature mean average, for example, is equal for ss and dot and the function that we would like to use. For example, for the average, we use dot average and the array of data that we will make the statistic for it. Okay, let's see the result of calculation of average. Here are the values. We are expecting 33 as an average value or something like that. Let's see the value. We save our file, then we refresh our application, then we see the output of our log. Okay, we can see here that the average is equal to 36 and the library simple statistics is working correctly. And now after testing our statistics library that generates for us the different statistic values for the temperature data, we are going to create first our four variables that will be used in the cards later. And now we are making some variables in order to use them in our cards. And we are logging them. We made some string operations in order to format our values. Here are the values, the max, the mean, and the average and the mean. And now before I explain to you the code for sending the data from the temperature component to the grid component, I made this schema in order to explain to you with it the details of child and parent relationship that I have made inside our project. Okay, so what's happening here is that the child component is creating an output event which will be triggered whenever a new data is coming. And it is then calculating the statistics values. Then it sends them in the form of a JSON object, and the parent component is consuming it and displaying it. I will explain to you now using the code. In fact, here is my temperature component, and here is the event emitter that is created. I called it temperature stats created. And it contains one parameter which is temperature stats param. What's happening here is that this temperature stats param will contain a JSON object which is here, which have this format: max, mean, average, and mean inside the JSON object, and it's appended each time. Then it is sent through this method, this emitter, to the parent. And in the parent side, in the HTML parent side, here in the selector of the temperature component, we have here the method of the child which is the temperature stat created, and here the method of the parent, and inside the field we made a console log, just a console log, and after this test you can see here console log here that the data from is sent successfully from the child into the parent object, as we can see here. Then we are going to use this data inside our cards here. And now, before I explain to you the code for sending the data from the temperature component to the grid component, I made this schema in order to explain to you with it the details of child and parent relationship that I have made inside our project. Okay, so what's happening here is that the child component is creating an output event which will be triggered whenever a new data is coming, and it is then calculating the statistics values. Then it sends them in the form of a JSON object, and the parent component is consuming it and displaying it. So I will explain to you now using the code. In fact, here is my temperature component, and here is the event emitter that is created. I called it temperature stats created, and it contains one parameter which is temperature stats param. And what's happening here is that this temperature stats param will contain a JSON object which is here, which have this format: max, mean, average, and mean inside the JSON object, and it's appended each time. Then it is sent through this method, this emitter, to the parent, and in the parent side, in the HTML parent side, here in the selector of the temperature component, we have here the method of the child, which is the temperature stat created, and here the method of the parent, and inside the field we made a console log, just a console log, and after this test you can see here console log here that the data from is sent successfully from the child into the parent object, as we can see here. Then we are going to use this data inside our cards here. Then we create a temperature stats object, which is similar to the one that we have created in the temperature component. Then this temperature stats will take the value of event data dot temperature stats param, which is coming from the child component. After that, in the HTML of the grid component, which is the parent component, as I said before, I added the event here. Then we add the start the function of the parent here, and as we are sure that the temperature stats here contains the new data and its statistics, we add in each card the corresponding statistic value. For example, here in the first card we are adding the maximum temperature, and here the minimum, and the average, and finally the mean. And here are we are sure that the data is dynamically added to our cards whenever a new data or an update of the actual data is done. We can see here that we have that the statistics are dynamically added. If we make a test, for example, and we open the Firebase console, and we open our project, we open the Firestore database. If we add a new document, and we add, for example, a low variable such as 1 degree, we should see here that the minimum value in the card of minimum value will be 1 instead of 2. But we should first add the time, which is of type timestamp, and we add the date of today, the time now, and finally we click on save. Okay, we can see here that 1 degree is set in the minimum card. Then after that, if we add, for example, the temperature of value 19, for example, and then we add the time as always, which is of timestamp, of type timestamp, and the date. Okay, we can see here that the maximum is modified and also the average and the mean, which means that our application is working dynamically and representing real-time values. And now, in order to create our project and upload it into our board using VS Code, we have to install this extension, which is Platform.io. I have already installed it, but you have to click on install, then wait until it's installed. Once it's installed, you will see an icon here. And when you click on it, you can go to projects and configuration. And, you can create a project by clicking on this button. So, for example, we will create a project named real-time dashboard. And the board that I am using is Vmos D1 Mini. We can use the default location, and we can choose a custom location. For example, I will use this location. Then we click on finish and wait until the project is created for us. We can see here that the project is created for us. It contains the source folder, which contains our main project. And here we should add our code. And now, in order to work with Firebase, we should add the library Firebase client, and to do that, we have to go to our extension again. Then we have to click on libraries. Then we have to type Firebase client. We can see here that this is the library that we can use. We click on it. We can add it by clicking on this button, add to project, or we simply can copy its declaration. We can copy this declaration and paste it inside our platform IO in ini here, deep depths. We wait until it's added to our project. Okay, once we save this file, we can see that the next library is the NTP client that we will use in order to get the time. Then we wait until it is added into our PU libraries folder. And now I am going to explain to you using the following diagram. Then I will explain to you the code that translate this algorithm. Okay. We have here the ESP8266, and inside of it, it will get the temperature value and the time value. Then it will they will be put in inside Firebase JSON, which will be then sent in the form of a document to Firebase. Okay, I will now explain to you using the code source. Here we have our main file, and inside of it we have the declarations. And now I will explain to you some parameters that we should get from Firestore in order to authenticate our ESP8266 Wi-Fi module. Okay, so to start, we go to Firestore here. We click on the project that we are using. We click on authentication. We can see it here, or if it is not appeared here, we can search it here, the build. We click on it. We click on Sign-in method. We click on Add New Provider. Then we click on email and password. We go to users tab. Then we add a user by clicking on add user. We create an email and password. Then we click on add user. I already created a user. The email and the password that we added, we should add them here. I will explain to you now where these parameters are used. These credentials are used in the authentication object, okay? Firebase authentication object. And this Firebase authentication object is taking as parameters the user email and the user password. Then it is used by the firebase.begin function, which start the connection to Firebase. Let's return to the top of our code. We can see here that there is another parameter that we should get from Firebase console, which is API key. We go to our Firestore. We click on our project again. We click on this setting icon, project settings. We can see here web API key, which represents the API key for our application. We add it here. Okay. This API key is used by the configuration object, which is a Firebase configuration object. Then this configuration object is used with the authentication object to start the connection with Firebase. We return again to the top of our code. We can see another parameter that we should get from our Firebase console, which is Firebase project ID. In the same place where we got the API key, we can get the project ID also, which is here. We copy and paste it here. This Firebase project ID is used by the function that is called create document, which creates the document for us. Then it sends it to Firestore, which is located in Firebase. And finally, concerning the Wi-Fi credentials, they are representing the Wi-Fi name and the Wi-Fi password that we are wanting that our ESP8266 connect to it. I will give you the link of this code in the GitHub, so don't worry, you can check it later and see the details again. And now let's continue. We have to create a Firebase data object, then the authentication and configuration object, and the time that will generate for us the time, and the NTP client object that also will help in the generation of the time value, the timestamp that will be the time variable for us. Then we have the function getTime that return time in the etc format. In the setup function, we have to connect to Wi-Fi, then wait until the Wi-Fi module is connected. After that, the authentication object will get the email and the password so that the user will be authenticated. Then we increase the size of the RX and TX buffer for large data handle. We limit the size of response payload because maybe we will get a huge amount of data that is coming as a response payload. So we have to reduce the size of it. Then we have to start the connection with Firebase using begin, and inside of it we put the address of the configuration and authentication objects. and we reconnect every time to Wi-Fi using this function. Inside the loop void here, every 60 seconds, which means 1 minute, we create our JSON object and we set the path of our document, okay, which will be the name of our collection to push data slash the name of the document, which will be data plus a counter that will be increased every time. Then we send static values in order to test our algorithm and our code. We set the a random value for the temperature, and we set the actual time using the get time. And this time is taking UTC format so that it will be parsed successfully by Firebase. And here the counter, as I said, it is incremented each time the loop is executed. And the essential part is here. It is the creation of the document. Inside this function, we have to put the content dot row, which is containing the temperature and the time values, as I explained, to print a message. Creation of the document was successful. Else, we print the reason why there was an error during the send of the document to Firebase. And here are the icons that are responsible for the compilation and upload of the code in the ESP8266 Wi-Fi module. They appears in VS Code once we add the extension platform IO to it. Now we click on the compile or build icon to check if there are some errors. It takes some time. We wait until the compilation is finished. And after it finishes compilation, we can see a success message. If we got an error message here, we should check the cause of the error and make a debug and solve the error. Then compile again until we get the success message. Then we can upload the code to the ESP Wi-Fi module. This our Wi-Fi module. It's linked to the USB cable, and the other side of the USB cable is connected to our machines. We click on the upload icon. We wait then until the code is successfully uploaded. Okay, I removed the cable and put it again in the USB port. Then it is uploading successfully. We wait until it finishes the upload. Okay, now we should see the terminal. By clicking on this icon, we can see the output of the serial.println or print that we made in our codes. It is connecting to Wi-Fi now. And as you can see here, the Wi-Fi module connected to Wi-Fi, then it was authenticated. Then it created the documents and the response from Firebase was with the JSON object of the document that was sent. And here we have data 0, data 1 until data 3, which contains each one the time when the data was sent, plus the temperature, which is a random value between 1 and 100, as we can see in our code. And now let's run our Angular application to see whether the dashboard is getting real data from the Firestore, which is itself is getting real data from the ESP Wi-Fi module. Let's type ng-zorro and wait until the server is created. And now the ESP is connected to Wi-Fi and is trying to send data to Firebase. And we can see that the first data was sent. It is here, and it is added to our dashboard. We can check it. You can see here the value is 11. The timestamp is here. Okay. Now the second value is added. It is here 92, and the statistics are also updated each time a new data is sent. We will wait 40 seconds as mentioned here by our code. We can see, okay, now the third data is added, 40 the third value. We can see in Firebase, okay, it's added now. We can see that it is added also here. We have three data. Here is the 40 values. It was sent at 4 hour and 20 minutes. This way we are sure that our ESP Wi-Fi module